Hello and welcome to NARC Live on Wednesday the 15th of January 2025, coming to you live from Norfolk on the east coast of England with Tammy N0AX.
Hello.
And me, David G7URP. Lovely to see you. On tonight's show, we learn all about earthing and bonding the shack with Ward N0AX, seasonal club news and views, and we will remind you, well, we have the mystery item set nearly a month ago now, and we ask you, what on earth is this? But first, I'm afraid we have to start with some sad news. Martin French, G8WSH, is silent key. Martin passed away on the 31st of December 2024. He was born in London, lived in Essex at Mersey Island, and lived in Long Stratton in recent years, and became a member of club for the last 5 years. He served in the Royal Navy, left service in 1972 as a petty officer radio electrician, and then he retired. Martin French, G8WSH, silent key. Our thoughts are with his family and friends. Now, as I'm sure many of you have seen, we have a new website. If you have the newsletter regularly, you'll hopefully be receiving that now. It's been a lot of work. I really want to thank publicly now Mark G0GJ for all his work on this. It is a much more modern website, but we haven't done it just to make it look a bit flashier, even though you should find it much easier to read, particularly on a lot of portable devices and mobile devices. But also it's going to make us more secure, and we have to be more secure because even if we don't want to change, the web changes, the internet changes, and the security that goes with it. So we do have to make those changes. You will notice that things like the forum are now back, and you can buy and offer things for sale and wanted. And also we'll be able to have things like a future shop and things on there where you can pay securely online. So this was a really important thing that we needed to do. Now, this is how it looks right now. We hope that you'll all get used to it. If you haven't already done so, you should be receiving the newsletters. We managed to carry the numbers over. What we couldn't do, as you often find if you buy a new phone or a computer, even if you try and carry the data over, what we couldn't do is carry over passwords. So you do need to create a new password. So if you already had a login with your email address or your call sign, most commonly for our own website, you will need to set up a new password. An email was sent to everybody, but if you didn't receive that email, or maybe you destroyed it, I know some people thought it might be spam, and maybe we should have actually told everybody we were doing it ahead of time. But if you did do that, don't worry, because if you know what your original username was, which I said in most cases was your call sign, then you can just go to the website, go to sign in, and put in your original username, your call sign, and then ask for, say you've forgotten the password, and then it will send you a link to reset your password, and then you'll be in. You can look at most of the website without that, but there's a lot of other things for members only, and if you do want to post anything in terms of for sale or wanted items on the forums, then you will need to be able to sign in. On the website, there's an article which Mark found, and he thought he'd try and make the website rich with other things. And one of the things that he talks about is these paper newsletters. Now, this is one from April 1992. Actually, I'll hold up to that camera, Tammy, if you could sort of zoom into that and close up on that. This is an original paper one. Actually, this is one that he scanned, and I've reproduced in the original green paper that it was. I thought you'd be interested just to see this before I tell you why I'm showing it to you. This was the club programme for 1992, and it makes interesting reading. This is on our website, so you'll better look at that. And also, there was the chairman's report. And as someone who's been a chairman of this club for quite a while, I was intrigued to know who was the chairman in 1992, and it was, I bet he's watching this and he's going to know, Mike, G4DYC. There we are, and that's a letter that he had when we used to do a good old-fashioned printed newsletter. There was an advert there for the Anglian Rally as well for July. Look at that. And lots of useful stuff. Now, I was looking around, and Mark is basically asking if you have some of these newsletters from the old days of the club. He's only got, I think, 3. Then please, can you either scan them and send them to him or to me, or if you don't have a scanner, or if it's going to take you ages because you haven't got a sort of an automatic scanner, then just give it to either myself at a club meeting or to Mark. And we'd love to scan them in and put them, because they really do make interesting reading. I mean, by the way, on the back, there's propagation tips for the spring 1992 by Jim Bacon, G3YLA. So there we go. Some things don't change, but a lot of things do, and it is really interesting to look back at it. Now, while I was looking for that, because I thought I had some, and I hope this will be a nice surprise for our member who now lives in Poland, because I found this in a folder, and it's from the Shortwave Centre at Collindeep Lane, Sprowston in Norwich, and it was run by Paul Gunther, G4XBT. And you'll know Paul, and many of you I know. And this was something I found. Paul, this is an original, so if you would like this for your collection, if you haven't got anything like this left, I'd be very happy to keep it for you or post it to you. There's even a compliment slip from him, look there. I just thought you'd find that interesting anyway. So do have a look round. If you've got an old bit of memorabilia for the club, although it would be nice to think these paper things exist and survive. Of course they won't indefinitely, but it's nice to be able to, if we can scan them in, we can put them on the web for lots of people to enjoy, and it hopefully keeps them for longevity as well. Excuse me. We're both suffering from colds, I might as well tell you that. So if you hear coughs or anything from tonight, then you'll know that's us, I'm afraid. Now on to some other things, and next Wednesday, a week from today, we're meeting at the school, at CNS School, as the usual times between 7 and 9:30. As well as a social informal, we ask all of you who are interested in contesting, whether you're already seasoned contesters and enjoy taking part in club contests, or you're maybe new to the hobby and you want to take part and find out what contesting is all about, either on HF or VHF, we have a meeting that night, next Wednesday, to discuss what club entries are going to be, where we're going to work from, what equipment we'll need. I know we had some issues with a rack of equipment last year and things like that. So this it's one of the first meetings of the year, is to refresh. So if you're interested in contesting with Norfolk Amateur Radio Club in the next year, please come to that meeting and have your say. Malcolm, G3PDH, will be chairing the meeting. The meeting will start at 7:45, by the way. My notices will be about 7:30. We open from 7. My notice is at 7:30 and then 7:45 for the contest meeting. And just another reminder, as far as club news is concerned, that the membership is now due for 2025. If you haven't already done so, and I know many of you have, these are the details. If you were already a member during 2024, all you need to do is just send us £10 for the whole year and just put your call sign as a reference. If you weren't a member, but you now want to join, we will ask you to fill in a membership form, and you can find that on our website, which is norfolkamateurradio.org. Now, before my voice gives out completely, I'm going to just tell you about some other events and local news. There's a local military radio event. You may have seen this on the newsletter or the website. I'm just going to tell you briefly about it. It's Operation Mana and Operation Chowhound, were humanitarian food drops to relieve the famine in Holland behind Nazi lines late in World War II. This year commemorates 80 years, and there are plans to mark the event with special event stations and awards, including the 100th Bomb Group Memorial Museum at Dickleborough near Diss. The organisers of this Norfolk station are now looking for radio amateurs who can help them run the station at various times over the weekend of April the 25th to the 27th. And I think we've got a slide here to show you that. So that's the magic dates, especially I think if you have an interest in amateur radio and military equipment. But anybody, of course, would be welcome to go and help run that. They've come to us as a local club, and any other club, of course, in Norfolk, any other amateur even, will be welcome to take part. But we do need to start sort of getting names and things now. So if you would like to take part in that, like to know more details, just drop your name on a quick email to me. I'll collect those interested, excuse me, and then we'll get them. We'll collect those names together and we'll get them to the organiser of that station. It's at Diss, so very nearby. And a couple of bits of members news. Firstly, from Gordon, G3PXT, he's opened a new gateway in Norwich. The gateway is at his QTH. It's now on air on the frequency of 430.025 megahertz, so UHF, with a 94.8 CTS tone. It's a part of the Northwest All-Star Group, and he's got, in terms of an antenna, a V2000 at 14 metres, and it's 38 metres above sea level in total. He says that everybody is welcome to use it. It's got a 3-minute timeout. Note that it's a gateway, not a repeater as well, Gordon has said. Any other questions you can ask Gordon yourself, either on the radio or on an email or at the next club meeting. And he says already there's lots of UK, EI, ZL and VK users and nets online. So thank you, Gordon, for putting that up and making it available to everybody. And then one little bit of picture that I found, actually, to give us something to put on the screen. Many moons ago now, I think it probably last year, maybe even the year before, we talked about, some of us, with an uncouth way of testing batteries. And I said as a kid, I remember putting 9-volt batteries to my tongue, and if it sort of stung and tingled, then it was okay. And some of you agreed with that and said, oh yeah, it's a totally normal way of doing it, and others were horrified. Well, we found this on Facebook recently, and we just couldn't resist showing it to you. And he says, could be the battery. He's testing it now. Okay, that's pretty much it for us. We have got a video of the 3D printing evening that we had at the school last year, but we had a couple of technical problems. Last week. But we're going to show that the next time. So if you did miss the 3D print evening, and you'd like some information, by the way, on some of the things that you missed, Martin G7UGB, whose inspiration it was, has put us some contacts together, and you can find them on our website and on the newsletter. And we also did a video of that evening. He's also let me have a copy of the slides. So if you did miss it and you'd like to see a copy of the slides that he showed in an informal presentation, I could send them to you. But next time we meet here, we'll be sure to show you the videos that we took on that evening. Tammy, over to you for Little People, and let me rest my voice.
Here's the Little People for this week then. This intrigued me because it was called Tangled Incident.
Oh.
And I thought, how many times have you had a tangled incident?
Are you asking me?
Well, yeah. You don't get it as much now, though, do you, with the
with Bluetooth and things,
with wireless phones? But it tickled me. So there you go.
Very good.
This week's.
Lovely, thank you. Miniature-calendar.com. Looks like a crime scene.
It is a crime scene.
Yeah. Thank you very much, Tammy. So, what have you been doing? I haven't had a lot of news from you, really. We had that piece from Gordon. I had that yesterday, I think, or this morning, maybe. But we'd love to hear from you. We'll be meeting again here in 2 weeks' time for NARC Live. So do drop us any news, pictures, anything that you've been doing to radio@dcpmicro.com. The usual email address is on your screens now, and we'd love to hear from you. Now we're going to look at the competition that we did way, way back. In fact, it was the 4th of December. I look back, so it's over a month ago. And we showed you this picture and said, what on earth is this? And over that month, we've had quite a few entries as well. Do you know what that is? I'm just having a look.
We just had one online from Mike.
Mike, Gaey. We'll start with him then. It says the mystery item looks like a magnetic mount dial gauge. Okay, Stevie G3EVA said, I believe that the item shown this week is a zero setter used for setting work in milling machines and lathes.
Ray G4LUA, it's a Z-axis dial gauge with a magnetic clamp for checking tooling distances, etc. on lathes and milling machines. Can also be used to check the run out on car brake discs after replacing them.
Ian Paget said it's a CNC zero setter.
Tom G8XQD looks suspiciously like a precise surface gauge.
Bob G6PWS, I hope it's a milling or machining gauge to set the tool distance reference to the machine table. He's hoping that because else it's the new type of sewing machine.
Richard G0VCW, it is used in engineering and I believe it's a Z-axis or axial preset gauge used with lathes, milling machines or CNC machines.
And Tony M0TDK says, is the current what on earth a dial test indicator, familiarly referred to by users as a clock. The circular lump of steel attached to it is probably a magnet to hold it in place whilst measuring stuff on a lathe or milling machine. Fairly good consensus of opinions there.
Yep.
And Tammy, it is?
It was, a tool length presetter, but I suspect it has maybe a different name to that technically, but that's what it does.
And they all described it, didn't they?
Yeah.
So I think everybody gets a point for that.
Absolutely.
So it's just for fun, though. No prizes. Goodness me. What would the treasurer say if we thought we were giving prizes away? Well done to all of you. Thanks very much to Mark 2E0YUU for sending that picture in. It certainly... I wouldn't have known what to call it. I think I might have worked out what it was for, but I didn't know what the proper name was.
It's a thingamajig.
It's a thingamajig for the What's It. So let's have another look at another thingamajig for What's It and ask you, what on earth is this? Our guest in the States, I can see him looking closely at the camera. He's really looking closely. I think this is a fascinating item. I'm not allowed to say anything, am I, more than that, Tammy?
No, what we can say is we actually have this item in our possession because that is our lovely desk here underneath. So next time we will actually physically show it to you. Yeah. That's all we're going to say though, isn't it?
It's pretty much all we can say, isn't it?
Yeah.
I'll tell you what.
No, be quiet.
It was given to us by somebody, I think, who... Well, anyway, what is it? You tell us. You're very clever out there. I know that some of you all know. I'm not allowed to say any more.
No, you're not.
It's not worth my while trying. Let us know. You've got just under 2 weeks to let us know by 3 o'clock on Wednesday week. Send your answers to radio@dcpmicro.com. Now, before we meet tonight's guest, it's just time to tell you what's happening at the club this week. We're kind of back to normal, I think, the normal routine of things. On Sunday, we've got the GB2RS News at 7 o'clock, or GB3NB. On Monday night, the GB3NB. Also, we've got the net at 7:30. And it really is open to anyone to run or join the net. It's not really fair for one person to have to run it every week. And it's really simple to do. You don't have to do it formally. All you've really got to do is make a list of the people that are on it and go back to them. So please, others, step up. Otherwise, it makes it very onerous for one person to doing it all the time. So it'd be nice to see a few people doing it. Also, at 8 o'clock on Monday, the CW net on 3.543 megahertz. Now, next Wednesday, as I mentioned as well, January the 23rd, that is, we've got a meeting at CNS School. It's between 7 and 9:30. Both a social, informal, and a meeting of everyone interested in HF or VHF contesting. So please do make a date for that at the school next week. And also, of course, we'd love to see your stories and your mystery objects. And of course, as you know, we'll always send this card to anybody you think will be cheered by a card from your club. We'll add your name to ours and send it to anywhere. Just send me their name and address and what you'd like me to put inside it. So now we meet our guest. Probably not before time because I think my voice might give out if I don't have something to to smooth it out first. All of us are aware of things like the wonderful, pretty stuff and the sexy stuff like the aerials and the actual transceivers and things. But some much more basic stuff that you need to do in the shack, like earthing and bonding. And tonight we've got an expert to come and tell us more about it. For the first time, I think, on NARC Live, it's welcome to Ward, N0AX. Hello, Ward.
Good afternoon, good evening. Glad to be here, David.
Yeah, it's lovely to see you. You haven't been on NARC Live before, have you?
I have not.
No, well, you've eluded us for the last 5 years since we've been doing this. But it's really good to see you, and we're looking forward to your talk. As always, if you have any questions you want to ask Ward or any comments or anything at all, you can ask them during the talk or straight afterwards, and we'll read them to him at the end. But I'm now going to hand over to him for the talk on bonding and earthing. Thanks very much, Ward.
Okay, thank you. I'm happy to be here. Appreciate the invite. The mystery device, I think the new one, I believe that's a Victorian era fermenter for brewing. That's my suggestion. So who knows what really.
Well, thanks. We don't normally get people to suggest it before, but I'm not allowed to say whether I think that's right or wrong. It's not worth life wouldn't be worth living if I did this. So, but thanks for the thought.
Looked old and it looked dangerous. How about that? Okay. All right then. Well, anyway, thank you for inviting me. I'm glad to speak to the group, and I thought I might go through my presentation and change all the references to grounding to earthing, but thought I would leave it alone and let the local experts translate. Of course, here we are, two nations divided by a common language, and we have uh, different references for different things. But at any rate, this talk grew out of some columns I wrote for the ARL's QST some years ago, and it turned into a book, and there is a lot of interest in this for a variety of reasons. And so this talk about earthing and bonding for home stations covers three basic areas of interest. So the goals of the presentation are to understand the difference in the way Americans use the word ground. You would probably use the word earthing for most of what we refer to as grounding, but there is a difference between this connection, whatever it's called, and bonding, which is connection between devices. I'll touch on the different requirements for AC power safety, lightning protection, and RF management in the station. And we'll discuss issues and techniques that are involved with home HF stations. This is primarily of concern to HF installations. VHF installations have their own challenges, and certainly mobiles do too. But we'll stick with the fixed home stations, and you can extrapolate from that. What I would like to reinforce is a common system of approaching these problems satisfies all requirements. You don't have to have three different types of systems, one for AC, one for RF, and one for lightning. One common system will satisfy the requirements for all three. I do touch on some special issues for mobiles, and then we'll provide comprehensive resources at the end. I have provided a PDF document to David that contains these slides, and so you don't have to be writing notes all over everything. You can download the slides later. So let's get going. Here's my favorite set of ham radio references. The ARL handbook and the ARRL antenna book both have a lot of this material in them. I was the editor of both for some time and was able to carry information into those. And I don't know, some of it's probably been picked up by the RSGB. At any rate, those two books are widely circulated. Another pair of really excellent articles are Lightning Protection for the Amateur Station, written by Ron Block, NR2B. They were in the 2002 QST. They're publicly available on the ARL website. And I should mention that Ron, who was associated with Polyphaser for many years, which is a protective component manufacturer, he's also written and released a new book called Lightning Protection, and that's available online. So Ron's stuff is really good. There are a couple of really good websites out there for you. First is from Jim Brown, Kilowatt 9 Yankee Charlie. And if you simply do an internet search for grounding and bonding and K9YC, you'll find his website. There are lots of papers on it. The two most involved with this topic are power, grounding, bonding, and audio for amateur radio. Jim is a retired audio engineer, and he's written what has become the ferrite Bible here in the States, RFI ferrites and common mode chokes for hams. WHAY's website is also very good. Tom, WHAI, lives on the top of a hilltop in Georgia in the southeastern United States and has a 300-foot tower on it. So he knows a lot about lightning. And then for mobiles, the K0 Bravo Golf website is your go-to resource. And then I particularly like this book. This is the second edition of the grounding and bonding book. Covers AC wiring, all these things, lightning protection, RF management. I had some really good reviewers. Everybody thinks I'm some kind of a big expert on this, but really the reviewers, which included Ron Block, the ARL lab, some lightning consultants, K9YC, others, they really contributed a great deal to this book. And there are numerous examples to use in the book. It's a toolbox. It's not a step-by-step. The problem is too big for a cookbook approach, but it describes what the problems and issues are and how to address them for your particular circumstances. So let's talk about what is ground or earth anyway. And it has different meanings. It's a widely overused word. It can be a noun where it's talking about an earth connection. The English reference to earthing is much more literal, and I think it's a better word, but we've come up with using the word grounding, and so that's just the way it is. It can be a noun referring to a specific thing, like an earth connection. Can also be a local reference potential. For example, they talk about ground in airplanes, but I've never seen an airplane dragging a chain yet. So they can deal with ground without having an actual ground or earth connection. It can also be a verb, which is an action. I'm going to ground this and connect to the reference potential. And it can also be an adjective referring to a type of a thing, such as a ground conductor or a ground system. And it can mean all these things at the same time. So you get these strange sentences like at the bottom of the page, I'm grounding the chassis to ground with the ground wire. And it means different things all three times. So you have to be very careful about the way you use ground or earthing. Okay, so there's some interesting concepts about this, and people tend to think that the earth is some kind of a magic sink, and it's not, into which we can pour all this RF and just pour it in there, and lightning goes right in there, and magically it safely disappears. Same for the vehicle body in a mobile station. Somehow it maintains this 0 volt reference, and it's not true at all. The earth is just like a circuit. It's made of dirt and soil, which have resistance, and so we mustn't assume that it's just a magic 0 voltage point. There are also some fuzzy definitions. We throw around the phrase RF ground. There really is no such thing. There's no miracle point or surface which is always at 0 volts, no matter what the frequency is. It can only be a reference potential or voltage, and only over a relatively narrow frequency range. So be careful when you use that term as to what you intend it to mean. Also, ground loops are very commonly referred to. It means any continuous path between pieces of equipment, and so that are connected to the enclosure or your ground rod or earthing point. They're not really the problem everyone seems to think they are. Mostly they are interesting at low frequencies where they can pick up magnetic fields, but at higher frequencies the ham station is full of ground loops. Look behind any ham station and you'll see dozens of them. So we can deal with that. Single point ground is an electrical power reference where the electricians will have you connect all your grounds to a single point to prevent error currents in your system from flowing through equipment. And up at lightning frequencies, then it really refers to trying to bond everything together so that all the voltages change together, go up and down together. You're going to see me do this a lot through the talk. That's a very interesting and common way of referring to what you're trying to accomplish. You want all of your equipment to be at the same voltage, no matter what that is. So each set of requirements, AC, lightning, and RF, use the word differently, and you have to be careful. So let's jump over to bonding. That's where we use the same word, you and I. It's simply a connection intended to keep 2 points at the same voltage. If you go look up the definitions, that's what it is. I'm not talking about how I bond. I'm just simply talking about making this connection to keep the 2 points at the same voltage, and so that everything goes up and down together. Um, the idea is to prevent one piece of equipment from being up here while the other one's down here, or vice versa. When you have different voltages between pieces of equipment, that's what causes current flow. And so by minimizing voltage differences, you also minimize destructive current. It prevents shock hazards from voltage differences. If you have all your equipment bonded together and properly connected to a safety reference point, then if one piece of equipment has a problem, it won't suddenly be at a hazardous voltage. So bonding prevents shock hazards from voltage differences. And if you have a lightning surge nearby, it's the destructive voltage differences between pieces of equipment, even if that's for a very short period of time. And electricity is a lot faster than we are. The voltage difference is what causes the current flow, and that is what is destructive. So by bonding equipment together, you minimize the amount of current flow between pieces of equipment during a lightning surge. It also limits current between devices caused by RF pickup. RFI is not caused by the voltage, it's caused by the current. And the current gets into places where it should not be. And that causes the equipment to misbehave. So if you minimize the voltage between pieces of equipment, you minimize the current flowing between them, and that helps reduce RF interference. Okay, if you're going to approach bonding, and to be successful at bonding, it has to be low impedance, and it has to be electrically short at the frequencies of interest, so your conductor doesn't start acting like a transmission line. And that generally means much, much less than a 20th of a wavelength, so that any phase difference across this connection is minimized. It also has to be heavy enough to carry the expected current. If we're talking about grounding in an audio circuit, these do not have to be heavy conductors. But if you're talking about bonding in for lightning protection, then it might have to be a very heavy conductor indeed. So it doesn't vaporize basically when a large current surge goes through it. So whatever your intent for the bonding connection, you have to know what kind of maximum current it's going to carry. It also has to be sturdy enough to survive what happens to it in the environment. And that's why when you look at your building codes and you talk about outside earthing conductors and whatnot, they're much larger than you might expect. Over here in the States, we would get into number 6, number 8, number 2, rather large conductors as big as my little finger. And part of that is mechanical, because the buried conductors outside are going to be subjected to being driven over. You're going to hit them with the shovel when you're digging in your garden. Don't ask me how I know this. And all kinds of other mechanical insults. So you want your conductors to survive that outdoors. And if they don't and they break, suddenly your connection may be gone and you wouldn't even know until there was a problem. What about inside? In your ham station, the standard over here is a solid strap, copper strap or aluminum strap, usually copper, 20 gauge, which is not particularly heavy. It's about a 0.5 millimeter or less. Or heavy wire. Number 14, which would be typical for an AC circuit, all that spare wire that you have in the box under your workbench, because you will never throw anything away. Guilty. That's perfect for this kind of application. If you have to use a braid, for example, your equipment is moving around, you want to roll something in and out or pull it in and out of where it's installed, use the flat weave tinned braid. You've got to protect that braid from moisture and chemicals. Don't ever use it where it's going to get wet or dirty or get nasty chemicals on it, because as soon as you do, it begins to oxidize. And once it begins to oxidize and develop that coating on the little wires, it no longer acts as a single conductor. And it can, first of all, start to exhibit some serious resistance and impedance, and it also generates noise where those nonlinear contacts were made between wires. Another typical ham desire is to use old coax, and we take the jacket off, and then we loosen up the braid, and we take off the braid, and it's nice shiny copper, and we say, oh, what a lovely conductor. Well, the problem is, as soon as you take that jacket off, the braid is exposed to oxygen and it's exposed to water. Both of those attack the copper and develop the oxide coating. The other thing is the jacket is what compresses all those little wires together. So you have those wires braided together, and the jacket holds them tightly together. Once you take it out of the jacket and we loosen it up to get it off the center conductor, then all those wires start to loosen up. They no longer are making good connections between each other, and so that braid begins to degrade immediately. If you want to use old coax as the braid from old coax as a conductor for this, just leave it in the jacket. Put a terminal on it at each end, waterproof it, and just treat it like a big wire. That's the way to use it. When you do this bonding correctly, use the right conductors, the materials, and all that, it works in your favor for AC safety, lightning protection, and RF management, all three. So, AC safety grounding. It has several names. I don't know exactly what all the names are in England, but over here, the current reference phrase is equipment ground. And it can be also referred to as the third wire ground, the green wire ground. It depends on where you are, basically, and what your electrician has been trained to refer to it as. But that is basically a conductor that goes back to the AC service box and provides a connection back to your AC source. The idea is to keep your ground connections, these safety ground connections, low resistance. That's the most important thing. It's not inductance, it's not RF impedance, it's resistance. And the purpose, there are two purposes for these conductors. One is a path back to your AC common point for fault currents, such as short circuits and leakage. And the conductor has to be heavy enough so that when there is a fault, it can conduct all of the current the circuit can provide, and that will cause your protective components like fuses or circuit breakers to open up and remove power from the circuit, and that prevents shock hazards and fires. The other thing that these connections do is stabilize the AC power system voltage. There's thousands and thousands of these earthing connectors on power poles and at your service entry and all kinds of other places like substations. And none of them are particularly good, and certainly one of them is not enough. But when you have thousands of these in parallel, it stabilizes the AC power system voltage during faults and transients, such as lightning, or perhaps there's an auto accident and knocks the lines into each other and that kind of thing. It helps the entire system from going to really high voltages, and so that it's a stability thing. But that's the only two reasons you have AC safety connections like this. Over here, we find that in our big hardware stores, all of them have some kind of a book that says how to wire your house. And this particular one, written for the U.S. market, is by Black & Decker, and it's called The Complete Guide to Wiring. It's not expensive. It's $20, so what is that? Somewhere between 10 and 15 pounds, I suppose. But these are not expensive. They're out there. They're written by experts. And I know we can all kind of rough out a branch circuit or something like that. But once you get beyond the least complicated and most simple wiring task, you really need to do it right. So you can find one of these books and it will guide you through it. The other thing that we have here in the States is called the National Electrical Code. And it's a little book of rules and regulations that all the electricians have, and the building inspectors have it and carry it around and like to open it up and point at this and tell you what you did wrong. But for the average person, you need more guidance than that. So there's a handbook written about this code. Now, it's a much bigger book. This is the example here. This is the National Electrical Code Handbook, and perhaps there's an equivalent over there, and it gives you a lot of rationale for what these regulations are about. And they have pictures for how to do it properly, descriptions, really good descriptions of what they're trying to get you to do. So this is often available at the library or used online, and they don't change very much. We're basically interested in the chapters on grounding or earthing and on antennas, and those don't change very frequently. So if you can get a copy of a handbook like this, it's much easier to follow. I must tell you that there are special rules in both of our countries for sub-panels, and I know many of us like to install a sub-panel for our station or perhaps out in the garage or an outbuilding. There are special rules for wiring these so that you do not create an electrocution hazard by improper earth connections. And please read those and follow them, because people are injured or killed every year because of improper wiring. And then finally, after you do the work, hire a professional electrician to take a look over your shoulder, or perhaps do the work in the first place. A house fire or an electrocution is not something to trifle with. And over here, the local building code is the law, and we refer to that as the authority having jurisdiction. Perhaps it's a building department or some kind of local municipal office, but typically it's a legal requirement to follow the code, and you might be able to get away with not following the code to a certain extent, but if there's a fire or injury, you may find yourself liable. So it's good to know what the local code is. Let's jump to lightning. You can't steer lightning, and I really don't know how common lightning is on the Emerald Isle. I used to live in Seattle, Washington, where it was so rare that if there was lightning, they would write about it in the newspaper. But now I live in the Midwest, and it's much more common. And if you have ever visited Florida, you know they have lightning almost every day. It comes from way up in the air, 10 miles or so, and you're not going to be able to steer it when it gets down to within 20 or 30 feet of the ground. But you can help it make good decisions about where it goes. So what does lightning want? It wants a heavy, direct path to the earth so it can dissipate charge imbalances in the ground. Either charge is coming down and flowing into the ground, or charge is coming from the ground and going up into the cloud. Either way, give it a heavy, direct path, because that's what it wants. And if it has that path, it'll try to take that. Most of the current will go that way, as opposed to wandering around looking for nice radio equipment to destroy. In this kind of a path, inductance is more important than resistance. Inductance in the path, because you have a sharp, sudden change in current, that creates enormous voltages. The equation is the inductance times the change in current with time. And so if you get kiloamps per microsecond, it doesn't take very much inductance to make a significant voltage. So you want to minimize inductance. And all of these low inductance, heavy direct paths should be outside your residence. Do not invite lightning into your house. If you have an earth connection, a system, a lightning protection system, it should be outside the residence. Don't run lightning protection conductors through your attic, through your crawl space or basement underneath the living area. Just don't do it if you can at all avoid it. So don't make it easy for lightning to go through your station on its way to the earth. All these protective paths should be outside. You'll hear a lot of discussion of a thing called single point ground panels. SPGP is the abbreviation. What that does is it bonds the grounds of all the entry paths through your feed lines, your rotator controls, your data, your telephone, your satellite, all this stuff. You want it all bonded together and connected to what's called a perimeter ground, which is something we'll talk about later. And that's a ground system outside your house. So you want all these things tied together so you don't get big differences in voltage between the reference voltages, the earth connections of your different systems. And you have a telephone system, you have a home entertainment system, you have a satellite system, you have data systems, you have AC, you have your feed lines and other stuff. You do not want lightning size transient voltages to occur between these different systems, because then it will cause the destructive current flow that causes fires and blows stuff up. You want all of your protectors to be mounted on this single panel if at all possible. And the reason you want them mounted together is so that they fire, meaning they begin to conduct protective currents at the same time. Lightning transients are very short. They're just maybe a few milliseconds. And so it doesn't take very much time if you have your protectors separated, one over here, one over here. You'll get a really significant voltage over here with respect to this. And then later, it might even reverse and go the other way. And these can be kilovolts, tens of kilovolts in size. And so you want all of your protectors together so that all of the systems go up and down together. And that minimizes voltage between them and the destructive currents. This also, the grounding of these protectors on the panel, and that should include, I'll just reiterate, your non-RF and AC power. If you can mount your single point ground panel, sometimes it's referred to as an entry panel. If you can mount that near the AC service entrance, they've already got an earth electrode there for protection. Bond them together outside, and that helps minimize inductance and keeps the voltages at the same level. When you run your cables, and we'll see a drawing of this in a minute, what's important is to keep the protected cables, which are downstream of your protected devices. You want to keep them together, and you want to keep them away from the cables that might be carrying destructive voltage services, transients, surges, I meant. So that when a surge occurs, you don't want that energy to jump across your protectors to where the protected cables are. So you keep these bundles away from each other. It looks nicer if everything's nice and neatly bundled together, but by doing so, you compromise your protected devices. So keep the protected stuff and the unprotected stuff away from each other. Here's a drawing. This is a typical entry panel for a ham station where you might have, let me find my cursor here, you might have the good old lightning arresters here that we know and love. You might have some additional protectors for a rotator or control line. Your data or phone lines are over here. And I'm pretty sure that in your neck of the woods, or your country, as we say, um, that the individual service providers, like data, telephone, satellite, whatever, they are all required to have some kind of an external earth connection. So if you create this perimeter system where all of the earth electrodes, these ground rods here, are connected together, that's called a perimeter ground. Everything should be bonded to that. And the closer they are together, the lower the inductance is between all the different systems. So here's your protected lines right here. The are unprotected. They're the ones that come in from the data, the rotators, the antennas, all that kind of stuff. You want to keep those away from the protected ones up here. You also want to run your AC power that powers your radio equipment. You want to put a protector for that on this panel as well. Yes, you want to run your branch circuit to this panel, mount the surge protector on it, and then run some kind of a circuit back to your station. If this is conveniently located at your station, that's not so difficult, but it might take some wiring in a typical installation where the station is not right up against the exterior wall. Here's some examples. This is K4RO. He lives in Tennessee, which is in the southeast of the United States, and he lives on a hill, and that explains his good signal a lot of the time. But Kirk was losing a lot of equipment in his antenna system to lightning, and every time there was a thunderstorm, something would get fried or blown up, or something would stop working. So he finally got tired of that, and his actual station is somewhere above this panel. This is a big piece of aluminum that he mounted in his garage. It's under the house. They have a two-story house where the cars are in here, and the living quarters are upstairs. So he mounted this in the garage, and he put everything pertaining to the antenna system on it. His filters, his switches, his routing stuff, and then he connected that with this big wire that goes through the wall to an external ground system. That's where his earth electrode is. And then the RF cables all go up through a hole in the floor to where his station is. And since he's done this, since he's bonded all of these individual pieces together and connected them with a low impedance direct path to the earth, he has lost exactly 0 pieces of equipment. So it really does work. It takes some effort at the beginning and some attention to detail, but it pays off. Here's another example of a very small single point ground panel. This is at the base of one of my towers. I have 3 60-foot towers that are on a relatively exposed point here in the middle of the United States. At the bottom of each tower is a surplus fiberglass electrical box, and I mounted antenna switches on it. I mounted these gas discharge tubes right here, and this is my rotator control line. This is my antenna switch here. So all mounted on just a simple piece of aluminum flashing mounted in the box. And here's a big heavy wire, number 6 American wire gauge. It's about 6 millimeters, and it goes to an external ground rod. So everything is mounted to this before it heads toward the station. I could save you some money here. If you look online, you'll find irrigation system or sprinkler system control cable. This particular stuff here is 10 conductor. It's number 18 AWG, and it works really well as a rotator control cable, and it's a lot less expensive than the special rotator control cable that you buy from ham dealers. You can buy that stuff for going up the tower or making a movement loop or inside your station. This stuff is direct burial, coated with PVC jacket, and you can even double up some pairs to provide the heavy-duty solenoid brake circuit. And then these are 75-volt gas discharge tubes that I buy in bulk. They cost about $1 a piece, and they are all grounded. They're connected with sheet metal screws to this ground system here, and that protects my rotators along with this antenna switch being mounted to a ground panel as well. Okay, you need to bond all of the earth connections outside your residence together. That's required by law in the United States, and you can see our ground rods here. I might have one for my electrical panel, one for my telephone service, one for cable television. If I mount an antenna on my house, I'm supposed to run a heavy wire down to an earth electrode of some sort. And so if these are not connected together with wire, what are they connected with? Well, they're connected with dirt. And the connection, the resistance of dirt is pretty high. If I took a voltmeter or took a ground resistance measurement between these different ground rods around my residence, I might find 10 or 20 ohms between them on a good day. And what happens if there is a kiloamp surge that flows through the dirt? And that is not at all unusual if you have a nearby lightning strike to have 1,000 amps for a short period of time flowing through the soil. So 10 or 20 ohms times 1,000 amps is 10 or 20 kilovolts. And that's what would be the voltage difference between, say, my electrical service and my telephone system when there was a nearby lightning strike. And that would generally be enough to blow up my telephone system. And so we may have all heard stories about people sitting there during a lightning storm. Suddenly they see a flash, and then there's this big arc between their computer and their home entertainment system, and now nothing works anymore. Well, it's because the ground systems were not connected together. And so when the current flows through the earth, you get these big lightning differences as it flows through. And the voltage difference is enough to cause some serious damage. So you want to create what's called a perimeter ground with all of these external electrodes connected together with a buried wire between them. And you can use either mechanical clamps or cadmium welding, where you actually weld the wire and the ground rods together. That's outside your house or your residence. You want that to go around as much of the residence as you can, because your antennas are out there exposed to lightning and other problems from a lot of different directions. So that's called a perimeter ground. And you don't want these low impedance paths to go through your station. Here's an example. Here's a tower with an antenna on the top of it, and Mr. Lightning comes along here and either hits the tower or it hits something close to the tower, and you get serious current flowing down the tower. Because of the inductance of that tower, you can get several kilovolts of difference between the tops and the bottom. So here comes the lightning, and it flows along your cables, and you have this nice entry panel here, and some of the current will flow to this ground earth electrode here, but the rest of it will flow along your feed lines to your radios. And then it'll flow through the system, your power supply, your branch circuit, over to your AC service entry, and then into another ground electrode over here. So that's destructive right here. This is what kills your radios. Here's what you want instead. So everything's grounded, your tower, your entry panel, your AC power system, and every one of these ground rods, every 10 to 20 feet, is bonded together with this buried wire here, right there, and that gets over to your AC service entrance. So if Mr. Lightning hits the power lines, for example, and comes in on your power service, and it says, okay, some of me is gonna flow along this ground connection to a ground rod here. And some of it's going to go through this unprotected AC circuit. But if you've got your AC power protected on that panel, then most of the current is going to go out to the earth electrode the way you want it and not through your radios. Lightning current is no different than any other type of electrical current, and it will divide according to the resistance that it sees in each branch. So give it lots of branches to go outside and dissipate into the earth and not have to flow through your equipment on the way to a ground. Here's another drawing. Here's your basic lattice tower. This has been a common drawing in the ARRL literature for many years. Here's a concrete tower base under the tower right here. And then each tower leg is connected to a nearby ground rod earth electrode. And then all of those are connected together with a heavy wire forming a ground ring. That's good. That's the way to ground a tower. But if you've got the shovel out, or you've got the guy with the digging equipment over at your house, then have him dig some extra long radials out maybe 30 feet from the tower if you can, and bury some more wire with ground rods out there. That forms a very good radial system under each tower, and that gives the lightning what it wants: a heavy direct path to disperse into the ground and dissipate that energy. So the more that happens outside, the better off you'll be inside. So you want these ground rods and radial wires hooked up to the bottom of your tower. You want to bond feed lines to the tower every 50 feet. This is a typical bracket that mounts on a tower leg, and you can see that this feed line goes up to the antenna. These are the antenna wires, and then these are the feed lines to your shack. And you want to bond to the tower every 50 feet or so, because when you get hit by a lightning strike and there's a lot of current flowing in your tower, the inductance is enough to cause several kilovolts, sometimes tens of kilovolts, between the top and the bottom of the tower. If your feed lines are not bonded to the tower, they are at a wildly different voltage, and that's where you get damage to the cables, jackets get torn up, water gets in, all kinds of bad things happen. So even though it's kind of a pain, every 50 feet or so, you want to put one of these grounding or bonding brackets on your tower and make sure the feed lines are connected to the tower. If you've got an insulated base tower, I have that on mine. You want to create a spark gap around the insulator so that if lightning does hit the tower, it builds up a big enough voltage to arc over your spark gap and get to your ground system on the tower. Let's jump to RF management. And everything in your station is an antenna. No matter how it's wired, any length of wire close to your antenna system at HF is going to be an antenna. You think about it, say 40 meters, what's the wavelength of 40 meters? Well, it's 40 meters, right? Okay, so anything closer than a couple hundred meters is right in the near field of that antenna, and it's going to pick up a lot of energy. So that includes your feed line, all of your RF bonding wires, your coax jumpers, your interface cables, even you and your mic cable are going to be part of that antenna system. Your safety grounds, everything. So you've got to just accept that, because unless you want to live in a steel shipping compartment, you're going to be picking up a lot of RF in your station. So we need to manage it instead of try to reject it. So the first thing is we forget about some kind of mythical all-band RF ground. There's just no way to create a wide frequency RF 0-volt potential across the frequency range that hams use, which goes from down around 1.8 megahertz all the way up into the VHF spectrum. So concentrate on doing a good job of bonding, connecting everything together. Keep your connections electrically short. even at the higher frequencies, so that the ground connections themselves don't start acting like an antenna or a transmission line. And the idea is to keep everything at the same voltage no matter what the frequency is. Keeping things at the same voltage, and they go up and down together, means the current does not flow between pieces of equipment. So that's what you want to minimize. If you've got an amplifier, which is high field strength, you've got to pay extra attention to bonding. If you think you've got a well-bonded system and you add an amplifier, trust me, you'll find where your bonding isn't quite up to snuff. You'll also meet the neighbors, but that's another situation entirely. So the way I suggest people approach this problem is to create a common reference plane, meaning a big sheet or surface, or a bus, which is perhaps a copper pipe, it's perhaps an aluminum angle, whatever, something that's easy to connect to so that all of the equipment can be at that same voltage. Here's a good picture. You may have seen something like it in the RSGB manuals, where you have a piece of copper pipe behind all your equipment, and then you connect every piece of equipment, including computers and unpowered equipment, like an antenna switch that's completely passive. You want to make sure that any exposed metal or metal enclosure of your equipment is connected to this RF bonding bus or ground plane. And if you do use copper pipe, use a ground clamp, because it is designed to maintain pressure between two metal components, whether they're wires or pipes or rods or whatever. If you use the little stainless steel hose clamps that you screw on and they tighten up, those are not designed for metal to metal contact. That is designed for metal on one hand and some kind of flexible material like rubber. Well, it's a hose clamp, right? So it's designed for to use the springiness of that material. And so those hose clamps loosen up over time. Well, you can see why that might be a bad idea. So use a ground clamp or perhaps a sheet metal screw and lock washer. And then your RF bonding bus here is also connected to your single point ground panel or entry panel or whatever you want to call it. So this eliminates hotspots inside your station, so that perhaps on 15 meters, say, you get RF burns off your microphone. Well, that's because your your microphone is at a high voltage. And so by connecting everything together in your station, you minimize these hotspots. It also reduces the buzz and the hum that's at low level for audio, and that's a problem because many of us use digital communication modes, and we use audio, low-level audio, going into our microphone jack. So by bonding inside the shack and eliminating this current, you also clean up your modulation audio. And this means that you can move equipment around in your station and you don't have to worry about suddenly creating some kind of imbalance or hotspot that would be a problem. It's just good practice all around. If you use a bonding bus, you look around in back of your equipment, any one of these paths that has a continuous path between pieces of equipment, that's a ground loop. And you will see dozens, if not hundreds, of possible ground loop paths in even a modest sized station. What you can do, you can't get rid of these because you have to connect your equipment together. Just minimize that loop area, use the shortest cables you can, and if there's excess cable, coil them up to minimize the exposed length. And I've been told that if you coil them in a figure 8, that reduces the inductance and the amount of RF that's picked up when the RF interacts with the loop. Use a bonding bus or a reference plane and connect all of your cables, route them along this bus or plane. Always use shielded cables for USB, for audio. I don't use shielded cables for power, but I use shielded cables for everything else, even if it's just a control switch or a signal to prevent RF from being picked up and conducted into equipment. Keep your connections short with straps or wires as much as you can. Here's an example. This is one of my stations. It's just on a banquet table. You can see the shiny part back here. This is aluminum roof flashing. It's 12 inches wide, and it's just screwed down onto the tabletop. And everything sits on that. All of the equipment is connected to it, and the cables all lay on top of it, and it helps minimize voltage differences between these different pieces of equipment. So let's review here. You have a single solid ground system made of these short, heavy direct connections that works in your favor for all three of these important systems: your AC safety, your lightning protection, your RF management, and it helps clean up your audio too. The best time to do this is when you're just starting to build a station, or when you decide once a year that you just have to take everything off the desk and rewire it because it's a mess. That's the time to put down this bonding bus or reference plane and do your grounding. You want to make sure that you bond all of these grounds and your protectors together so they fire at the same time, so that everything goes up and down together and you don't get these individual destructive transients. And when you use a perimeter ground system, that helps keep the lightning currents outside the building. Help the lightning get to the earth. That's what it wants. There are a lot of additional resources. I'm not going to go through these. These are listed in your in the PDF slides that I provided. So you can look at that. These are American references, but they're available online, and you can download a copy. Now, you won't have the budget as communication systems commercially or the military or that kind of thing, but you can look at these documents and you can say, okay, I see what they're trying to do here. What have I got in my toolbox and my budget that I can use to do something similar? What are they trying to accomplish here? How can I accomplish something with the resources available to me? There's some additional books here. Ron Block had his original book, and I think I showed this new one called Lightning Protection from Ron. And then the ARL Technical Information Service, even if you're not a member, a lot of this is available publicly. ARL.org/electrical safety, for example. If you go online and you look at the ARRL website and you go through the technology tab, you will find the ARL Technical Information Service. So electrical safety, grounding, lightning protection, all that's available to you at no charge, and you can look at it anytime. So I said I was going to touch on some mobile stuff, but I think I've pared this presentation down so it doesn't take hours and hours. There are longer versions of this talk out there online. You can find them on YouTube. You can find them on the ARL education website as well. And that's where I get into the mobile and other related sections. Plus, it's covered in the book. So at this point, I'll let somebody act as a interpreter or a relay station for any questions that may have been submitted, and I'm glad to answer them as best I can.
Thank you very much, Ward. I don't think you'll need an interpreter, but
David, you're muted.
Oh, I am. Oh, you're right. I apologise. I don't think we've ever done that, but it's because I've been coughing and stuffing in the background. And I didn't want to disturb you or anybody at home, so I apologise for that, Ward. Thank you very much indeed. Yeah, I don't think you'll need an interpreter, is what I was going to say. It's unusual for the guest to have to tell me I'm muted. I just can't get over that. Sorry. So if you've got any questions or comments and you haven't already done so, please do ask them now, either on Facebook Live or on BATC, where we are. We'd love to hear from you. I've heard from Tom, GAXQD, who says, today I buried a 33-inch long, 3/4 inch copper pipe as an earthing point for my antenna. I also provided some 48 feet to 65 feet radials from the copper. Do the radials work with my RF and or with the grounding for lightning strikes and lightning rejection? That's the first part of his question.
The answer is yes, those radials will in fact help with lightning protection if they are connected, as I assume, to the shield of the coax and the actual ground of the antenna. The lightning would have to jump from the active part of the antenna over to the radial part, and then it would disperse into the ground around the antenna. Typically, I think a small, a heavy inductor between the antenna and the ground system would provide a low frequency path without upsetting the HF properties of the antenna. You might want to check with the manufacturer on that. They may have already built that connection into the antenna. But vertical antennas that are ground mounted, yes, the radial field, the ground screen will help with lightning protection.
Lovely, thank you, Ward. As a second part to that question, Tom asks, should I connect all the radials at the closest point to the copper?
Oh, is the buried copper ground. For lightning protection, yes. The copper is buried more than several inches below ground. It probably will not have much effect on the HF properties of the antenna. But yes, connect anything connected to the earth, either buried or laid on top of it. Connect that all together. That will help with lightning protection.
Okay, thank you, Ward. Ralph 2M0RHT, who is our Scottish correspondent, as they say, he says that my third bathroom has some 6 green earthing grounding wires, as Scottish building regulations used to insist on excessive grounding. This I now understand, as we live a few miles from James Clerk Maxwell's house. Not boasting or anything, he says. Well, I'm sure you know who James Clerk Maxwell was. Andy M0NKR says he suggests that you use an outer braid of RG213 for strap grounding within the shack.
Okay, so he's got all these different ground wires that are going everywhere. Those should all be bonded together, and if wherever it's convenient, I suppose would be close to the equipment at the operating position. And so you would want to bond all those together with a heavy, short, direct conductor. If that's braid, that's fine as long as you keep it dry, and it could also be solid or stranded wire as well. Use whatever you've got that's sturdy, and I would say minimum of number 14 American, which is about a millimeter, maybe a little bigger than that. But make sure you connect it directly with short connections. I hope that answers the concern.
Thanks, Ward. Paul G3VPT says, in the 1950s, when working in the radio and television trade, many radio sets used a copper earth stake. One customer in a terrace house and concrete backyard had an earth stake in a flower pot just outside the kitchen window.
Mm-hmm. Yes. In those days, that was for a long or random wire copper antenna that would go outside, and the circuit for the current in the antenna went through the radio and then back out the connection to the ground stake outside. So that was actually, that ground stake is actually part of the antenna system there. With that being outside, you definitely wanted to have that tied into the AC safety, earth electrodes and anything for your ham station. But that came that came later when we started to understand what the risk was of having more than one earth electrode outside, not bonded together. But in those days, that long wire was actually had to complete the circuit to the earth, and that's what the function of that ground terminal was. It was not a safety connection.
Yeah, okay, thank you, Ward. So just a little bit of time now. If you haven't already asked a question or made any comments or anything on this and you want to, please do them shortly. I've got a message over on BATC from Martin G7UGB who says, great presentation. He says, I need to get my grounding sorted now. He says, I only have a simple end-fed half wave coming straight into my shack. Do I ground inside the house or take a ground outside for lightning?
Outside, wherever the feed line comes into the station, that would be into the building. That would be a great place to put a protector. Even if you only have the single feed line, there's actually a picture. Let me see if I can hold this up right there. You can see the ground rod here in the middle, and there are protectors here that attach directly to the ground rod outside. So basically, you'd run your coax from the end-fed half wave to the protector that's mounted on the ground rod, waterproof it, and then run another feed line into the house. I've got here in my city house, I've got an end-fed half wave, and the coax, I've got it buried. It's about maybe 50, 75 feet from the house. And it comes up, I drove in a ground rod, and what I did was I went and I found an inexpensive plastic, I guess you would call it a rubbish bin, trash can, and cut a hole in the bottom, put it over the ground rod, and the antenna feed line comes into that bin, goes to the protectors, which are mounted on the ground rod, and then a feed line goes up to my second floor station. So that's what I would do. Put your protectors and any lightning protection connection to the earth outside, and then run feed lines inside.
Okay, thank you very much. I was just looking actually online because you showed that book, and we believe the RSGB offer it. They certainly used to on an archive site. I haven't had quite time to find that, but I'm pretty sure they do. They certainly offer other books. For example, your hands-on radio experiments.
Yes.
They offer other books, so you can get them easily through the RSGB bookstore in the UK. It'll probably cost a lot less than importing them from the States.
The whole topic came from two hands-on radio columns, I believe, at the beginning of 2016. And in the 15 years that I wrote that column, those two columns on RF grounding and associated topics generated more correspondence by far than all of the other columns put together. There's a tremendous amount of interest in that.
Yeah, I mean, they're really good. I mean, they look good books from just the front of it. I think anybody who likes to experiment. As I said, if I'd have got it, we can't easily do that, but we'll put it on our website for people to link to afterwards. But it's really quite easy if you put your name in actually an RSGB bookstore, they come up. Excuse me. Andy N0AX says, I use a good quality copper earth rod held to the bench with pipe clips as a bus bar where everything is tied to, which then goes back to a buried earth rod, which is 3 sections knocked into one. So that's his solution. And I'm just trying to look here.
Let me jump in there. Yeah, you know, we've all used the copper pipe behind the equipment technique for many, many years. And that was very common because everything was available. It was you go down to the store and you could buy a couple of meters of copper pipe and that would be fine. If you use the flashing technique to create the reference plane, what I found, I don't have any pictures of this handy, but if you look inside your AC service box, you'll see these ground bars that have lots and lots of screws that mount in the metal box and they are for your neutral or your earth connection, and they're rather inexpensive. You can buy short versions of these things and mount them directly on your grounding equipment, and they already have screws and holes, and they're ready for any kind of a ground connection you might want to make from your equipment. So a bit of flashing, and these ground bars are a perfectly good alternate solution to the old copper pipe version. Go ahead. Back to you, David.
Thank you, Ward. Now from Tony G0MQG. He says a lot of radios in the 1950s in the UK had one side of the mains connected to the chassis of the radio. Grounding the radio chassis would cause the RCD to trip because of the mains neutral being connected to earth, because of course it detects, doesn't it? Not just for the live connection,
Right.
But for the other side. I guess that was that the same in the US, do you know?
Yes, it was, and it was quite a shock hazard, and it turned out to be a self-correcting problem, as they say. um, the uh, the idea was you would buy these radios on these inexpensive little steel chassis, and they were always in an insulating um, enclosure of some sort, wood or plastic, or some kind of like a Bakelite or whatever, and that's been outlawed now for years and years and years, but there are still some of them out there, and you have to be careful which way you plug in the AC plug. I think the British standards make it much harder to reverse hot and neutral. But for many years there were two wire plugs here in the States that, with each prong on the connector being exactly the same, and so you could plug it in either way. You just hope that you didn't do it the wrong way and then touch the supposedly ground side of your radio.
Yeah, I remember as a kid sort of getting into electronics, and my father was very cautious of me obviously opening anything, but I do remember on the back of a lot of things like old TVs and things, it said warning live chassis. That was often a very big warning written on the back of things, and I guess that's what they were talking about.
Yes, yeah, that's all been pulled either because it's unsafe or because it burned a house down, one of the two.
Yeah. I've just got one little thing from me, this bit. I mean, I'm it's been so useful, honestly, because although it feels like it's a kind of boring subject, but it's so important, isn't it? Not just from a safety, but from a performance point of view, to get these things right. But the one thing I remember you said, you've got all of your cables shielded except for the power cables. But if a lot of the noise is coming through the power cables and is radiated as opposed to conducted interference, do you not think that using shielded cables for power cables can be a benefit as well?
Well, you could. It doesn't hurt anything, but typically what I'll do is if I have a problem with a power cable, then I'll use a ferrite core and wrap it around several times. What I find is for radios and commercial equipment that the power connection is often really well bypassed, and they protect against RF coming in through the power probably better than almost any other piece of equipment you have in the station. So I typically don't have problems with power except on smaller peripheral equipment. And so rather than get into the shielded cable part of it, I use ferrite a lot. Type 31 ferrite. If you read the K9YC tutorial on ferrites, that is the mix that you need. And you need a group buy and just need to have a half a dozen of those around your house for use whenever you have a problem. Type 31.
Brilliant advice to end on. Thank you ever so much, Ward, for sharing this, both for the presentation tonight and all of the work that you've put into your books as well, which are wonderful resources for radio amateurs. And we often say in the technical world, in the commercial world rather, professional world, books like that cost a fortune, but they're relatively affordable now, and especially, that the RSGB import them so that they'll be a lot cheaper to buy. So we hope you'll come back another day and talk about something different for us.
Well, I have a number of presentations I'd love to do so, and if things work out properly, Ellen and I will be on your side of the pond, so to speak, for World Radio Sport Team Championship in 2026, and we're hoping
Excellent.
to travel around.
Well, as you may or may not know, it's actually not only in the UK, but it's really near here. I mean, this county,
Yep.
we're in Norfolk, is where a lot of the stations will be based. In fact, we had a presentation just before Christmas, which we recorded, from the WRTC team led by Mark, N0AX. So it will be lovely. If you do come this way, we'll actually get to meet you as well.
Oh, that will be fun. We're planning on making a grand tour. You may or may not know I've been associated with the WRTC since its beginning in 1990, and I'm just delighted to see it travel to England. And I know that it's going to be northeast of London, where the stations are. And I tell you, if you have an opportunity to volunteer for these events, it's great fun, and it may be some work, but it pays back huge benefits. You get to meet the most interesting people, and it's really a wonderful time for everybody.
Yeah, well, thank you. It says that it's very, very local to us, as I'm sure most of the members watching this now will know. And the headquarters for that is just in Cambridgeshire, which is about sort of 45 miles away, something like that. So it really is all very local, and we look forward to meeting you then. Thanks again, Ward, for this evening and for all that you've done in the hobby. We look forward to seeing you in 2 years.
All right. Well, best regards to everyone, and we'll see you on the band, 73.
Many, many thanks, Ward. Thanks, 7-3. There we are. That's Ward, N0AX, who's been giving us a wonderful presentation on what is quite a tricky subject, but something we can't afford to ignore. So we're very grateful to him for that. We've got an offer as well before we go. Just a nice comment there from Martin, G7UGB. It says, a hot toddy for you and Tammy tonight. I guess that's an offer. So we'll see in about half an hour. Martin, I think it's probably what we do need.
Yep.
A dose up with something anyway. Thank you very much. And sorry for any coughs or anything that spoilt this evening. That's why I had it on mute. Just to let you know, remind you what's coming on this week at the club on on Sunday, the GB2RS News at 7 o'clock. On Monday at 7:30, the Monday Night Net on GB3MB, and at 8 p.m, the CW Net on 3.543 megahertz. Then on Wednesday, the 23rd of January, we're meeting at CNS School between 7 and 9:30, and at 7:45, there's a meeting which we invite you to come to if you're involved at all, interested in contesting with the club, to decide what the club's going to do, which contests we're going to do, where they're going to do them, what equipment we're going to use, and all those sort of things, getting those preparations done early in the year. And also, of course, we love to hear your stories, your mystery objects as well. We've been sent a few since I last asked, but if you've got a mystery object or a gadget or something that you think will fox people, do send them to us, and of course our card for anybody else. But thank you for joining us tonight, and we look forward to seeing you again on NARC Live in 2 weeks, or even better at the school next week. But until then, from Tammy M0TC,
Bye-bye.
and from me, David G7URP, take care. Bye-bye.